Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends. In this video, we are going to study about the transducers which are used for the measurement of thickness. Here we will study the various methods for the measurement of thickness, their advantages, disadvantages and applications. So let us start with our topic. Measurement of thickness found a wide variety of applications in industries where the measurement of thickness of the plates and sheets is important. So, for the measurement of thickness, various methods are used, and these methods are categorized on the basis of the method which is used for the measurement. Okay, so for the measurement of thickness, the transducers are used. Transducers are the devices which convert a non-electrical quantity into an electrical quantity. So thickness is a non-electrical quantity, okay, and this thickness is measured by converting it into a electrical quantity. Okay, electrical quantities like resistance, inductance is there, capacitance is there. So the changes in the capacitance, resistance which are caused due to the changes in the thickness of the material, that is a measure of the thickness. Okay, so depending upon the method which are used for the measurement of thickness, we can categorize these methods into the electrical methods are Electrical methods are those methods where the thickness is measured by measuring the electrical parameters like resistance, inductance and capacitance, etc., voltage, current. Okay, so in electrical method we have resistive methods, inductive methods, capacitive methods, ultrasonic methods and nuclear methods. So the electrical methods which are used for the measurement of thickness of plates and sheets or of a material, they are these 5 types. So first we will start with the inductive method for the measurement of thickness. Now in inductive methods, the thickness is measured by measuring the change in the inductance of the material. So these are a type of transducers. Now these inductive methods, they uses 2 types of transducers. One is the reluctance variation transducer, and second is the eddy current transducer. Okay, so in the reluctance variation transducer, the thickness is changing the reluctance and reluctance is changing the inductance. And whereas in the eddy current transducer, thickness is changing the eddy currents and eddy currents changes the inductance of the material. So in this way, the 2 methods are used which are using various methods for the measurement of thickness. First, we will study the reluctance variation transducer. So in this reluctance variation transducer, it consists of a U-shaped magnetic core. On that magnetic core, a coil is wounded, okay, and the circuit, because it is a U-shaped magnetic core, so at the bottom of this U-shaped, the test piece is being located, okay. So test piece is going to complete the circuit. Let's see the construction of this or diagram of this reluctance variation transducer. So this is the reluctance variation transducer. Here you can see we are having a U-shaped magnetic core. Core is there, and on this core the coil is wounded. Okay. Now this test piece is put here. So test piece is going to complete the circuit in it. Okay. Now due to the presence of this test piece, a magnetic field will be generated because core is wounded with the coil. Okay. Now because this test piece is completing the circuit, so this becomes a magnetic circuit. Okay. Now the reluctance of this magnetic circuit, it depends upon the inductance of the coil. Okay. And this reluctance, the inductance of this coil, it depends upon the reluctance of this magnetic circuit, and reluctance of this magnetic circuit depends upon the thickness of this test piece. So as this thickness is changing, the inductance of the coil is also going to change. Okay, so inductance depends upon the reluctance, and reluctance depends upon the thickness of the test piece. So if the thickness of the test piece is high, the value of the reluctance will be low and the value of the inductance will be high. So we can say that inductance and reluctance, they are inversely proportional with each other. Okay, so high thickness means low reluctance, and low reluctance means high inductance. So we can say that the inductance of this coil is a measure of the thickness of this test piece. Okay. So inductance is inversely proportional to reluctance, and reluctance is inversely proportional to thickness. So we can say inductance and thickness, they are directly proportional. If thickness is high, then inductance is also high. Now this was the case of the reluctance variation transducer when we are measuring the thickness of the magnetic materials. Now for the non-magnetic materials, because we want the presence of a magnetic circuit, and magnetic circuit will have the reluctance. So here the test piece was a magnetic material. Now for the non-magnetic material, there will be a different arrangement. On the test piece, here the test piece is located, And below this test piece we are having a ferromagnetic material. Another arrangements are similar. So this is the coil, this is the core, then we are having the test piece which is a non-magnetic material. Now this non-magnetic material, it is placed on a magnetic base, and the magnetic base, this ferromagnetic base is so thick that the reluctance of this magnetic circuit, here also magnetic circuit will be there because this test piece is completing the circuit, and the thickness of this magnetic base is so much that the reluctance is determined by the distance between the ends of this U tube. Okay. So, in this, for the non-magnetic material, this material is placed over a ferromagnetic base. This ferromagnetic base is having so much thickness that the reluctance of this magnetic circuit, or the reluctance of this coil, is determined by the distance between the ends of the U tube and the ferromagnetic base. And this distance is what? The thickness of the test piece. Okay, so indirectly we are measuring the thickness of the test piece which is non-magnetic in nature by measuring the change in the reluctance. So for the non-magnetic material, you can see that if there is an increase in thickness, there is an increase in the reluctance. If thickness of this test piece is increased, the reluctance is also going to increase, and if reluctance is increasing, then inductance is going to decrease. So that is the difference in the non-magnetic and the magnetic material. In the magnetic materials, if the thickness is increasing, the inductance is also increasing, but in non-magnetic material, if thickness is increasing, the inductance is decreasing. So in both these methods, for the magnetic and the non-magnetic materials, the thickness is measured by measuring the change in the inductance of the coil. Okay, so that is the reluctance variation transducers. The second type was the eddy current transducer. So the eddy current transducers, there is also different arrangement for the magnetic and the non-magnetic materials. Okay. So first we will study the measurement of the thickness of non-magnetic materials which are conducting. Okay. They are non-magnetic but they are conducting materials. So for them, it consists of a coil which is wounded on an insulated core. This coil is excited by an alternating current supply. So because the coil is wounded on an insulated core and the AC current is passing through it, so magnetic field is generated. Now this magnetic field is alternating in nature, so magnetic field is going to produce eddy current in the test piece. And these eddy currents, they are a measure of the inductance. Okay, so the coil is wounded across the insulated core, alternating current is passing through this coil, so due to that magnetic field is produced, and magnetic field is producing the eddy currents in the test piece. So this magnetic field of due to the coil and the insulated core, it is producing the eddy currents in the test piece. Now these eddy currents are also going to produce the magnetic field, and the magnetic field due to the eddy currents is going to oppose the magnetic field due to the coil. And due to this opposition of the magnetic fields, the inductance of the coil is going to reduce. So due to the generation of the eddy currents, there will be a change in the inductance of the coil, and this inductance is proportional to the thickness of the material. Okay. Now, as I have said that this method is used for the measurement of thickness of non-magnetic but the conducting materials. So it is measuring the thickness of both non-magnetic, conducting as well as non-conducting materials. Let's see the arrangement of this. This was the test piece whose thickness we want to measure. And this is the eddy current transducer. And this transducer consists of the coil which is wounded around the core. Now this test piece is a non-magnetic but conducting material. So it was conducting material, that is why eddy currents were flowing through it. Now what will be the arrangement for the non-magnetic and non-conducting materials? For that, the test piece is located over a magnetic backing. This is the magnetic backing. This is the test piece. And over it we are having the eddy current transducer. Okay, so this is a non-magnetic and non-conducting material. Now if the thickness of this non-conducting test piece is very large, So if thickness of this non-conducting material is very large, then eddy currents which are produced, they are very small and the inductance of the coil is very large. So if we see the case for the non-conducting material, here eddy currents are small and inductance is large, whereas for the conducting materials the eddy currents are very large and the inductance is low. So inverse relationship is there for the conducting and the non-conducting materials. So here the inductance is varied by the variations or the production of the either the eddy currents or the reluctance variation. So in both these transducers, reluctance variation and the eddy current transducers, the variations in the inductance are a measure of the thickness of the test instrument. Okay. Now with this inductive method, the metal coatings which are of thickness from 50 to 75 nanometer, they can be measured. Also the aluminium films from 125 to 500 picometers can also be measured. Okay, so such small thickness of the coatings or the films or sheets and plates can be measured with the inductive method. Now next method is the capacitive methods. Now in these capacitive methods, the thickness is measured by measuring the change in the capacitance. And these methods are mostly used when the material whose thickness we want to measure is an insulator. So in this, let's see first its construction, that what are its main part. So we know that in the capacitor we have two electrodes. Okay, two electrodes are there. So here also in this capacitive method there are two metal electrodes, and these two metal electrodes are placed along the two sides of this insulating material. So in that, here we are having the test instrument. Around that test instrument we are having the two electrodes. Okay, so this is going to form a capacitor which is having two plates and a dielectric medium in between. So we know that the capacitance of a parallel plate capacitor is given by epsilon A by D, where A is the cross-sectional area, D is the distance between plates, and epsilon is the permittivity of the free space. So this permittivity depends upon the dielectric medium. And dielectric medium, because if it is having small thickness, large thickness, so that is going to affect this constant and it is going to affect the capacitance. So here the changes in the thickness of the material is changing the dielectric constant, or we can say changing the capacitance. So insulating material is acting as the dielectric, and because as the thickness of the material is changing, the dielectric constant is changing, or we can say the capacitance is changing. So by measuring the changes in the capacitance, we can measure the thickness of the insulating material. So this was the insulating material. Around that we are having two electrodes. Here we are having the output. This is the insulating material. So this was the capacitive method, where the thickness of the material is measured by measuring the changes in the capacitance. Now next method for the measurement of thickness is the ultrasonic method. Now in the ultrasonic method, the ultrasonic vibrations are measured, and these ultrasonic vibrations are a measure of the thickness of the material. So in this ultrasonic method, the ultrasonic vibrations are produced, and these vibrations are produced with the help of a transducer, which converts the electrical energy of an oscillator to ultrasonic vibrations of corresponding frequencies. Okay, so different vibrations having different frequencies, they will be generated by the transducers, and that frequency of that vibration is an indication of the thickness of the material. Now in this ultrasonic method, as we are using the transducers, so there are two types of transducers. One is the magneto-strictive type, and other is the piezoelectric type. Okay, so there are two types of transducers which are used to produce the ultrasonic vibrations. Let us first study the magneto-strictive type transducer. These type of transducers, they consist of a magnetic rod, and this rod is placed in a coil. Now this coil is excited by an oscillator. Okay, so magnetic rod is there, and this magnetic rod is placed in the coil, and this coil is excited by an oscillator. So due to that, a magnetic field will be there, and that magnetic field is alternating in nature. So alternating field. Now this alternating field is going to produce deformations in the magnetic rod. So these deformations in the magnetic rod, like its length is increased, its thickness is going to reduce, and due to these deformations the vibrations are produced in the nearby environment. Okay, so this is the magnetostrictive type, where the vibrations are produced by using a magnetic rod. This magnetic rod is placed in a coil. This coil is excited by an oscillator, and due to that an alternating field is generated. This alternating field is going to produce deformations in the magnetic rod, and these deformations produces the magnetic or the ultrasonic vibrations of different frequencies. Now second is the piezoelectric type transducer. So in the piezoelectric type transducer, piezoelectric crystal is used, and on this piezoelectric crystal, when a voltage is applied, then that crystal is going to get deformed, or it is going to change its shape. So in this type of transducer, there will be a piezoelectric crystal and an alternating voltage is applied to it, and due to that this piezoelectric crystal is going to change its shape, and this change in shape is alternative in one direction. So we know that piezoelectric, it changes its shape when voltage is applied to it. So an alternating voltage is applied to this piezoelectric crystal. Because the voltage is alternating in nature, so the change in shape is also alternate in one direction and then in the other. And due to this alternate change in the shape of the crystal, ultrasonic vibrations are produced. Okay. So the difference in these two types of transducer is the method which is used for the for the generation of the ultrasonic vibration. In magnetostrictive type, magnetic rod is used, and in piezoelectric type, piezoelectric crystal is used. Let's see the circuit for this. So this is the piezoelectric ultrasonic transmitter which is producing the ultrasonic vibrations, and these vibrations are when passed through this test piece, it is going to generate different frequencies. So this is the fundamental frequency, this is the second harmonic. So by measuring these frequencies, we can measure the thickness of the test piece. Now this piezoelectric crystal, here with the help of this voltmeter and variable frequency ultrasonic oscillator, we are providing the alternating voltage to this ultrasonic transmitter. Okay, and due to that the frequencies are being generated in this. So this was the ultrasonic method for the measurement of thickness. Next is the nuclear radiation method. These nuclear radiation method, they are going to use the nuclear radiations like alpha, beta, gamma, or X-rays are used. Okay, so these nuclear radiations, they are obtained, either the alpha, beta, gamma or the X-rays are obtained from the radioactive materials. Let's see the arrangement for this nuclear radiation method. So this is the arrangement for the nuclear radiation method. Here an X-ray source is there. This is the sheet under test, means whose thickness we want to measure, and this is the sheet whose thickness we already know. Then these are the X-ray detector tubes which are going to measure the amount of X-rays which have passed through this sheet. Now these detector tubes, this output of them will be amplified, and on a center zero indicating instrument the thickness will be displayed. So that is the construction of this. So there are two detecting cells. Okay, from one we are having the sheet of having unknown thickness. Okay, and other is having a known thickness. Now, because we are having the two sheets, one is having unknown thickness, other is having a known thickness. So both the X-rays are passed through them. Now, if the thickness of both these sheets are equal, then the input to the amplifier will be 0. Okay, so amplifier is connected with the indicating instrument. So if amplifier input is 0, then indicating instrument will also indicate a 0 value. So this is the case when the thickness of both the sheets is equal. Now if any of the sheet is having more thickness or less thickness, so according to that the output of the amplifier will be changed, and the indicating instrument, if we are going to calibrate it in terms of the thickness of the sheet, then directly it is going to indicate us the value of the sheet. So in this way, X-rays which are penetrating through the sheet, the amount of X-rays passed is a measure of the thickness of the material. Now the advantage of using its X-rays for the measuring of thickness is that first, First is that here the thickness is measured without making any contact with the material. Okay. Also, the materials which are very rapidly moving, their thickness can also be best measured or accurately measured with the help of the X-rays. Now, not only the X-rays but also the gamma rays and beta alpha rays, they can also be used for its measurement. Okay. So, this nuclear radiation method, it is using the radiations which are emitted from the radioactive materials like the X-rays, the beta rays, gamma rays and the alpha rays, and the amount of the rays which have penetrated from the material, that is a measure of the thickness of the sheet or the material. So in this video, we studied the various methods which are used for the measurement of thickness of the materials. We studied the electrical methods here like the resistive method, inductive method, capacitive method, ultrasonic method and the nuclear radiation methods. In these electrical methods, the thickness is measured by measuring the changes in the electrical parameters like inductance, resistance and the capacitance and ultrasonic vibrations and the nuclear radiations amount. So I hope that this topic is now clear to you. Thank you.